Hey everyone, so I wanted to do a recording of solving the challenges for the client-side CTF from being logged into the VM. So I did a series of videos before about how to solve the challenges as a remote attacker from a remote attacking machine. Now we're going to do those from the logged in VM. So we're going to take a look at what we have when we log in. So I'm logged in as the low priv user. So we're the low priv user, right? And if we see what kind of privileges this person has, they don't have very much, right? So they have the standard set um, of low privileges that are assigned to a Windows default user. So the first thing we're going to do is we're going to take a look at the services and make sure that when I started this box up, everything was okay. Switch over to standard view with the vulnerable service that should be running. Where is it? VVV, vulnerable service. Okay, so service is up and running. So the first thing we're going to do is we know we're supposed to be auditing this service, right? So this is non-standard Windows service. Let's take a look at what's going on here. So we look at this and we see, okay, the path to the executable is C, program files x86, vulnerable service, which is a typo on my part, vulnerable service exercise, vulnerable service.exe. So now what we can see here is there are no quotes around the path to this executable. And what that means is that as Windows starts this service, it's going to treat every space as a possible execution location. What that means is it's going to go to the C drive and say, is there a program.exe? If there is something that is C:\program.exe, it's going to start program.exe. And then it's going to go to C program files x86. And if inside of the C program files x86 folder, there is something named vulnerable.exe, it will try to start that. And then it's going to go to the vulnerable service folder and look for something called vulnerable.exe and try to start that. And then we're actually at the actual executable, so that's our last thing. So we have three possible locations that it could try to start this in. So let's take a look and see if we can write to any of the locations. Did I forget to close the dialog box? I didn't think I did. Maybe I just clicked too fast. There we go. Okay. So let's take a look here. So let's go to C. Can I create something in C? I cannot. So I can only create new folders. I can't write new things in here, right? So I don't have control over the C drive, so I can't do anything there. Program files x86. Can I do anything in here? No, I cannot. I have to have admin privs to even create a folder, so I can't do anything in here. So then I go to the vulnerable service folder. Can I do anything in here? I can. I can create whatever I want in here. As proven by, we can do test.txt, and it lets us create it. So we can create something in here that would allow us to hijack that. So what we've got here is I have this service executable that I created that's going to create a new user. So let's take a look at the users that exist. Let's do this. We're going to go to manage, computer management. So the users that exist right now on this computer, on this VM, are administrator, default account, guest, low privs, and standard. So low privs is our low privilege user, right? Standard is our administrative user. So what we want to do is we want to hijack that execution path, like I said, and this service.exe that I've created, that I have here, what it's going to do is it's going to go through and add a new administrative user to this machine. That's how we're going to prove that we were able to execute or exploit this vulnerability, right? So if we take service.exe and we copy it into here, and then we rename it, so we got to rename it so that it actually triggers the service execution. So vulnerable.exe. So if we name it that, now what we need to do is we need to stop the service and restart it. Now, normally a low privilege user shouldn't have rights to stop and start services. That's another vulnerability that's on this machine that we would notice is that a low privilege user can actually stop this service. So that's a misconfiguration, that's a vulnerability, right? So chaining these things together make it a vulnerability that allows us to compromise this machine. So now when I start this service again, I'm going to get an error because this is not an actual real service. This is this service that I created that should go through. And if remember, these are the user accounts that exist so far. So when I refresh, now there's a user account called hacked that is a member of the administrators group. because we were able to have write control to a location that we should not have had write control to. So we'll go ahead and delete this. Actually start the service again, and I lost my mouse. So start the service, and the service should start as normal. So now we have this user in here, right, that tells us that we can now control this machine. So we're going to open up computer management again as our new user. And I cannot remember the password that I put in for that user, so we'll do this one instead. Okay, so now that we're running this as an admin, I'm going to go back to the local users and groups. Let's delete this user, this hacked user, right? Delete him. Okay, so now what we're going to do is we're going to take a look at the permissions on the actual service itself. So because I am a low privilege user, I'm still the low privilege user. I just opened that one thing. I just opened the computer management pane, the plugin as the elevated user. I'm still the low privilege user. So because I'm still the low privilege user here, I shouldn't be able to do anything inside of this folder, but I can. I can put files here and I can rename files here, which means that I have full control over this directory. So what I can do is I can rename this to old.exe, and then I can copy in our service hijack, right? And I can just rename this to vulnerable service.exe. And because I have control over that, now when I start the vulnerable service, you'll see same error again, right? But now we'll look and the hacked user is back. So because I have write access to a folder where a service is running, I can just replace that service with whatever I want, and I can get privilege escalation. So the idea behind privilege escalation is if you start out as a user with a low set of privileges, you want to get the most privileges that you can. For Windows, that's the administrative user at the local machine level. There are other levels of user permissions along the way in orgs and domains. We're not going to talk about that. But for this local machine, once we're an administrator, we can then take complete control of it. There are other things we can elevate ourselves to, like NT system, but that's trivial once you're an administrator to elevate your privileges up that far. So the goal here is, as an attacker, we want to elevate our privileges on this machine so that we can control all of the data, control everything about it. In the other series of videos, I show you a little bit of what you can do post-exploitation that will kind of explain why we want to be an administrative user, right? So that we can harvest that data, passwords, all that kind of stuff. So we've got those two things, right? So those are the two things that we found so far. Now let's go ahead and find those two flags, right? So local disk C users, and then we want to go to the low privs user because that's who we are, right? We go to the desktop, there's nothing there. We go to documents, and here's user.txt. So this is a flag that says that, hey, I was able to access this VM as this low privs user. And then we want to look here and standard. Now, I should not be able to access this user's files as a low privilege user, right? There should be a boundary between the low privilege user and the high privilege user from being able to access their files. But it's a vulnerability that you can access those files. The ownership on these files is wrong. And so here's root.txt. And root is the normal naming convention for the highest privilege user in the Unix system, Unix or Linux system. And so that's just kind of a standard thing for capture the flag events in the information security world. So we have the contents of root.txt there. So it was a vulnerability that I was able to view that as the low privilege user. Okay, so let's talk about some of the other vulnerabilities with this service. So we've already taken a look at the vulnerabilities of the unquoted service path. We took a look at the vulnerability of, excuse me, the unquoted service path and then the bad service ACL, right? So access control list. We were able to change that service even though we're not a high privilege user. So now what we're going to do is we're going to take a look at this through process monitor or procmon, right? So we're going to fire up procmon and we're going to say, okay, We need to be an administrative user to use Procmon. And we're going to profile the vulnerable service.exe. And let's take a look at what this thing is doing. Okay, so it's doing some stuff with, it is trying to read files in the Windows directory. We as a low privilege user shouldn't have access to that directory, and I didn't make it so you did have access to that directory, so you can't do anything there. And then the first thing it's trying to do, so we'll kind of start at the top and work our way down. So the first thing it's trying to do is it's saying, okay, look in C DevTools for a backup.exe, and if that's found, it appears to be trying to start it, and it says name not found. So it's trying to reference something that's missing, right? So let's go take a look at the C DevTools folder. So the DevTools folder is empty, but we as a low privilege user have full control over this folder. So what that means is I can create files, I can edit files, I can basically do whatever I want. So this service is looking for a C DevTools backup.exe. So I gave you guys an add user executable for you guys to play around with that should add a user with a random username, but with a static password. And so if I rename this to, let's rename this to backup, right? Backup.exe. So then what should happen is the vulnerable service should try to run this backup.exe, and we can see it did. So let's go take a look at computer management and see what happened. We're just going to view users. We're not going to delete any from here on out, so it doesn't matter. So we don't need to do anything there. So let's take a look at users. As you can see, there's a new user that was added that is a member of the administrators group. So we were able to compromise this machine. We were able to elevate our privileges on this machine because we could write to a location that the service was attempting to access. So the service is a highly privileged process. It's running as the NT system account. Because of that, it's running and we can hijack the execution path. We can elevate our privileges to that of an administrative account. So this happens a lot. There are a lot of services out there, a lot of software where a highly privileged process is calling into a lower privileged process that standard users have write access to. And so this allows for a very trivial elevation of privileges, which is a bad thing. And so then the next thing it's trying to do is it's trying to look for a C DevTools helper.dll. So it's not just executables, it's DLLs as well. So anytime you're making a call out to anything, it could have been a batch file, it could have been whatever, right? It doesn't matter what it is. If we're calling from a highly privileged process into an area where a low privileged user has write access, then this can be compromised to give that user unlimited control of this machine. So just as a proof of concept here, we'll copy this and we'll just rename this to, and this isn't going to add a user because this isn't a real DLL, but if I just rename this to helper.dll, yep, go ahead and say yes. If I rename it to helper.dll, in just a minute, the server should try to load helper and we'll get our flag. So here's our flag for solving the backup. Here's our flag for solving the helper challenge, right? So we got 2 more flags. Now the last one is a little bit different. So what it's doing is it's looking in the registry and it's saying, okay, look for a key in HKey local machine, software, vulnerable service, and then it's trying to find something that says a value of vulnerable service cleanup script location. So what we can surmise here is it's trying to go into the registry and find this. So let's take a look. Let's go into the registry, HKey local machine, software, vulnerable service. Now let's take a look at the rights on this, the permissions on this registry key. So the users, every user has full control over this, just like an administrator. So what that means is we could create ourselves a registry key that says cleanup script location, and let's say C:\dev tools, because we know we already have write access to dev tools, right? So we might as well just put something in there. And let's just call this cleanup.exe. We could have made it whatever, right? We could have written a PowerShell script, a batch script. Let's just call it cleanup.exe. So if we rename this, so make a copy of the same thing, and we'll rename it to cleanup.exe. pretty quick, what we'll see is that the service will run cleanup.exe and we'll get our last flag of cleanup solved, right? So now let's go take a look at computer management again, and we'll see that we now have another user with a random set of names with that same static password that was added, and we got all three of our flags. So we found a location where we could control that we could either tell the service to look through the registry, or the service was already looking, and that allowed us to compromise the integrity of this machine. So these are common vulnerabilities that we see throughout the software world that we need to pay attention to when we're writing client-side software, right? These are common vulnerabilities that happen all over the place. People make this mistake because they assume that the highly privileged process is going to be safe, but it's not safe. Anytime the highly privileged process is calling outside of itself, outside of the scope of a protected folder, then it needs to do some integrity checking or validation on the DLL, exe, whatever that it's calling, right? We need to make sure that we're not allowing for elevation of privileges. Okay, so there's just a couple more things we want to look at. So we looked at process monitor, which allowed us to profile that. So now what we're going to do is we're going to take a look at the code. So we're going to use code reflect, and we're going to take a look at, so I gave you a service backup. So let's just take a look at the backup of the service, right? Because there's one more thing that we want to talk about here. So let's take a look at this vulnerable service, and let's take a look and see that it has some classes in here. A class called encryption, one called flag generator and flag writer. These are convenience things for me to allow me to create the CTF. If you want to look into what they're doing, great. Not super interesting though, just convenience things for me to be able to spit out a flag when you solve the challenge. Then we've got the service base, program, and task runner. So let's take a look at let's take a look at service one. And I lost my mouse there. Let's take a look at service one. And let's take a look at what it's doing. So service one on start is spinning up a timer. It's setting the interval to the timer, and it looks like it's setting it to like 5 seconds. And then it's enabling the timer, and then it is starting the timer and setting an elapsed event for it. So what that means is every time that this timer fires, it's going to do whatever is in this event, right? And so first thing it's going to do is run backup, then run helper, then run registry. So let's take a look at run backup. So run backup is going to look for the file cdevtools_backup.exe and also look for cdevtools backup solved. The reason I put this second conditional check in here is just so that it wouldn't just continuously create users. So once you'd solved it, as long as you left the flag in place, it wouldn't continue to call the executable over and over and over and create users. So then it would take the text backup solved, pass it to the flag generator, and write the result of that method call out to cdevtools backup solved.text. So it was looking for an executable, and we happened to be able to influence the executable that it was looking for. Same thing here. This one's just looking for a DLL, right? So this one's just saying, okay, does the DLL exist? If it does exist and you haven't already solved the challenge, then call run DLL32 and just start the process on that entry point. So we call it on cdevtools helper.dll, and we just call the entry point of the DLL. So these are contrived examples, but real vulnerabilities. And then the last thing that it's doing, again, is running a command from the registry. So it's going to open up the registry, look for this cleanup script location key that we talked about, and if this exists here, cdevtools cleanup solved, then it won't do it. Otherwise, it will look in that registry location, run whatever's there, put cleanup solved into the flag generator, generate a flag, spit that out into the text file, and you've solved the challenge. So that's the essence of what that's doing. So there's one more thing here. Let's take a look at the encryption. And what we'll notice is there is a string called encryption key and a string called initialization vector. So we have two strings that seem to be defined in the constructor that are hard-coded strings. So we have an encryption key that's hard-coded, and we have an initialization vector that's hard-coded. So what that means is that any secrets that were encrypted with these keys, with this key and this initialization vector, anyone would be able to recover. So anytime that your encryption key is included as a part of your source code, you are vulnerable to having whatever content you encrypt be decrypted. So I didn't actually have any encrypted text for anyone to solve. That's probably beyond the scope of what we're trying to accomplish. But this was more just a bonus thing that you could, if you found this, I wanted you to look into this and understand why it's bad to have a hard-coded encryption key and initialization vector, because then anything that was encrypted with this would be immediately be decryptable by someone who could reverse the code. Now, some people might be thinking, well, you can just strip it, you can just pack it. There are tools that exist to get around every form of protection that you can place around binaries. There's no form of protection that you can place around a binary that will prevent someone who has the right tools and enough dedication from recovering that clear text key. So putting your clear text keys inside of your application means that those keys are no longer valid keys, if that makes sense. So we've gone through, we've analyzed the service, we've seen what the service is doing. We've done it all from the GUI, right? The Windows login GUI. If you guys have any questions, please be sure to let me know. Thank you.